Question 44, triangle W, I can't read, triangle YWX is shown. That's that big triangle. Given WY is congruent to WX, picture shows that already. Given segment ZY, that's French for Y, is congruent to segment ZX, also French for X, picture shows that as well. Prove that segment WZ, that's this fellow right here, bisects angle YWX. So in order to prove that, we're trying to prove that angles 1 and 2 are congruent. Let's see what we can do here. Fortunately for us, part of the proof's already done. So we have the given done and done. Next, let's see what we got. Angle WYX, that's this angle right here, is congruent to WXY. That's this angle right here. Now, we can't show that in the picture very well that they're congruent, but why would they be congruent? Let's see Isosceles triangle theorem. It also says angle 3 and angle 4 are congruent. That's the same reason because it's in the same part of the proof. Also Isosceles triangle theorem. Let's see. No. This one. Base angles of an isosceles triangle are congruent. That's the isosceles triangle theorem. So that's going to go up here. Base angles of isosceles triangle are congruent. State test, that's a drag and drop thing. So that is finished. We got that one done. Not the whole proof, that step. Check this out. Then it takes these congruent statements and it makes them equations. Measures of congruent angles are equal. That's the definition of congruent angles, is what that is. It's already done. I got the next one. So the question is, where does this come from? Does it come from a previous step or does it come from the picture? I think you'll find that it comes from the picture. Referring to this step right here. Measure of angle WYX, let me just mark that for your viewing pleasure. WYX, that's this angle, is equal to measure of angle 6 plus a measure of angle 3. That's the angle addition postulate, right? Let's see if that's one of their choices. Here it is. Angle addition postulate. Once again, on the state test, it's drag and drop. Well, that's pretty easy so far, I think. We just got to take baby steps here. Let's just confirm. It also says that angle WXY, its measure is equal to the measure of 5 and 4, also angle addition postulate. Great. Confirmed. Then we got this next line here. Where does that come from? It says substitution, so that has to come from previous lines. So here's what's happening with this. They took this line here and they replaced the left side with 6 and 3. They replaced the right side of this with a measure of angle 5 and 4. That's substitution property that happened twice. Hopefully that makes sense. This next line we're missing, but we have the reason. It says substitution again. Not sure where they're going with that, but if I look at the next line, we just have 6 and 5 equal to each other. So if I kind of work backwards, that's telling me that 3 and 4 must be equal. And that tells us that right here. So what we could do is we could replace 3 with 4 or 4 with 3 since they're equal. And here is a step that says that. So this is going to be measure of angle 6 plus measure of angle 3 equals measure of angle 5 plus measure of angle 3. That is this one right here. Substitution. Then, to get from this line to this line, we got rid of measure of angle 3's. Well, that's the subtraction property of equality, which I don't see on here, but the addition property of equality is the same thing, so that's what that is. We are just chucking. Wow, we're doing a great job. Now we have this SAS. Side angle side theorem or postulate. This is in reference to two triangles being congruent. For that to happen, we have to have two pairs of sides in the included angle. So let's add some stuff to my picture here. This is referring to let me show you here. It's referring to this right here. We've got this side's congruent to this side's congruent to this side, and the included angles are congruent. That's side angle side. That's triangle WYZ, that's this one here, and triangle WXZ, that's this one here. So that's what's going to go on this next line. So getting to that point, that's getting a little tougher. Then the next line, which comes directly from this, it's picking out two specific angles, and it's saying those are congruent. That's what I said at the beginning. I don't know why they just don't use angle 1 and 2. Saying those are congruent to each other. Why? Those are corresponding parts of congruent triangles, CPCTC. They're not similar. They're congruent. So that's going to go into here. CP, CTC, once again, state test, drag and drop. And then finally, since we know those are congruent angles, that makes WZ a bisector, which is what this is saying. How do we know that? That's a definition of an angle bisector, which is this one. That's not easy. If you get 4 to 6 of those correct on the state test, you get 1 point. If you get all 7 right, you get 2 points.